All right, let's do 14 first. This is a motion along a line problem, and we're going to do it on the calculator. They want to know where velocity is increasing, which means acceleration as a function of time needs to be greater than 0. So let's go into the calculator and let's solve, or let's differentiate to get the acceleration function. So we'll plug in t plus 1 times t minus 3 cubed. And then I'm going to take the second derivative, so I go up to F3, calculus, choose differentiate, grab my function, hit enter, and then comma t, comma 2 to get the second derivative. And you can see my Leibniz notation there. Now clearly I have two zeros of the second derivative, at 3 and at 1. So if I were to do a number line analysis, which I'll go ahead and do over here at the bottom, here is my acceleration function, and I have zeros at 1 and 3. I'm going to go into my derivative, and my second derivative, I'm going to find out if the second derivative is positive or negative in each interval. So I'll come down to the very end of the derivative line, and I'll say such that x equals 0. And I get out, oops, sorry, not x equals 0, t equals 0. So type in t equals 0, and I get out a positive 36. So that means my second derivative is positive where t is less than 1. All right, now I'll plug in a t value of, say, 2. I'll find out that t is negative, and I'll go ahead and do t equals 4 and find out that t is positive. So that means that my acceleration actually changed signs at 1 and at 3. So where velocity is increasing, acceleration is positive. So that occurs at D, where t is less than 1 or greater than 3. All right, for 15, they're giving me a polynomial function, and they're telling me that a and b are constants, and that we'll have a critical point at 1 and 2, and we have to solve for both a and b. So what we're going to do to solve this is to differentiate to get f prime of x, which is 3x squared plus 2ax. And then we're going to plug in x equals 1 and f prime of x equals 0, because if we have a critical point, then when I plug in the x value, I get out f prime of 0. So that means I have 3 times 1 plus 2 times a times 1. So that gives me that 0 equals 3 plus 2a. 2a is negative 3, and a is negative 3 halves. So my answer has to be either a or d. So let's take a of negative 3 halves, and I can rewrite our equation. F of x equals x cubed minus 3 halves x squared plus b, and then just plug in the point 1, 2. So 2 is my f of x value. Plug in 1 for x, and I have 2 equals negative 1 half plus b, and b is 5 halves, so my final answer is A.